All right, class. So continuing on, section 4.3 is called More Discrete Probability Distributions. It actually covers two discrete distributions, the geometric and the Poisson, but we will not be covering the Poisson in this class. So we only have this one distribution to cover, the geometric distribution. You see only one slide. So this is similar to the binomial distribution in that it is a discrete distribution. A trial is repeated until a success occurs. The repeated trials are independent of each other. The probability of success is constant for each trial. And the geometric distribution calculates the probability that the first success will occur on trial X. So the probability the first success occurs on trial X is P times Q to the X minus 1. And this makes sense because I have one success and I have X minus 1 failures. So the first trial that my success can occur on is trial 1. It cannot occur on trial 0. So the values of X range from 1. The values it can take are 1, 2, 3, 4, 5, 6, 7, and it goes on forever, right? So the first success could occur on the 1,000,000th trial. It's unlikely, but it goes on forever. So this is a distribution where we want to use the cumulative distribution whenever we are looking for the probability X is greater than or equal to some number, because even though these numbers keep getting smaller and smaller, they do exist, and when we add them all together, so if I do the probability X is greater than 2, for example, I have to add in, X is 3, 4, 5, 6, 7, 8, 9, and keep going until this gets small enough that it's not counting, and small enough that even when I sum those numbers together, it's not counting. So it's easier to calculate the probability that X is, if I wanted greater than 2, it's easier to calculate the probability that X is less than or equal to 2, which would be that X is either 1 or 2, that my first success is on the first or the second trial, and then just subtract that from 1. So in this case, you're going to want to use your cumulative distribution. And also there is no function in Excel to do the geometric distribution. So we will be doing this by hand in Excel. All right, so let's look at a homework problem. And well, first, let's go ahead and set this up in Excel. Escape out of this. Okay, so the next distribution that we're doing is the geometric distribution. So I'm just going to go down here. Can't spell. Geometric. Okay, and this is the trial is repeated until a success occurs. X represents here, I'm going to use their wording. So X represents the first success occurs on trial X. So, and then the probability that the first success occurs on trial X is P times Q raised to the X minus 1. Okay, P times Q raised to the X minus 1. So all we're going to put in for these is P. We'll put in a value for P, and then we can calculate our probabilities. So let's look at some problems for this. All right, so assume the geometric distribution applies. Move this over a bit to make room. Assume the geometric distribution applies. Use the given probability of success to find the indicated probability. So it wants us to find the probability that X is 5 when P is 0.2. So what we're going to put in here is P, and then we're also going to put in our X. Okay, and our X is 5 in this case, and then I can calculate P of X. All right, so these are things that I input, so I'm just going to make those red as always. And again, the probability is P, oops. Oh, I need Q, hang on. I'm going to switch these around. Okay, and then I need Q. And remember, Q is just 1 minus P. All right, and then so our P of X is P times Q raised to the X minus 1. Okay, it's P because there's 1 success, and then there are 4 failures. In 5 trials, I fail 4 times, and then I finally get a success. So it's Q to the 4th, right, at times P, basically. Okay, so that is, and they want this to 5 decimal places, 1, 2, 3, 4, 5. 0.08192. Okay, and then our last question, describe the difference between the value of a binomial distribution and a geometric distribution. So remember what the definitions are, and you can answer that one. So it didn't have us do any like X is greater than some number. So I'm guessing on a quiz, this is all it's going to give you as well. But if it asked you, find the probability that X is less than 4, then you would add the probability of 0, 1, or sorry, there is no 1, 0. X starts at 1, so you would add 1, 2, and 3 together. Okay, so you would calculate P1, P2, P3, and you would add those together. And if it wanted the probability that X is greater than 4, then you would subtract that probability that you got for X less than or equal to 3 from 1. All right, so you guys are now ready to do numbers 9 and 10.